it is, in fact, one of a whole lot. There are more servers out there than I actually know about. So I couldn't tell you how many there were. I can see at least one or two people on the participants list who run their own Corpus CQPweb server, so they'll know. At the minute, there are two versions of CQPweb being used. Most people are using 3.2, which is stable. 3.3 is a newer version which has some bugs in it because of newer features being added. The Lancaster server runs on 3.3 because that's where I test things, and so you get the new features on the Lancaster server, but you also get any bugs. So that's the background. So as I say, 3.3 was is the newest version, and it was introduced to reorganize the data model that CQPweb uses. One of the issues that people have run into prior to version 3.3 is an unfortunate limitation in the database that CQPweb uses that means that it falls over and dies anytime you try to use a corpus that has any emoji characters in it. So that was a problem, especially as people now want to do Twitter data a lot, and there's lots of emoji in Twitter data. So version 3.3, which I unleashed on the world just over a year ago, was all about fixing that issue. At the same time, I made changes that I hoped would allow greater flexibility going forwards, because what I really want to focus on for this kind of phase of work on CQPweb is extensibility, in a particular sense that I will explain as I go. So why extensibility? Why is extensibility such a big thing for me, and why did I make it the center of the abstract that I sent into the conference? Well, the thing about open source projects is the reason that they're open source is so that other people, other than the person who does most of the work on the code, can actually work on it, right? So multiple people could, if someone wants to come and work on CQPweb, they can just look at the code, start typing their programming and add something to it and contribute. In practice, that's actually really hard. There is only one person that I know of at present, that other than me and Stefan, who has done a lot, who has done more than like 1 or 2 lines of CQPweb programming. And I had to help her a lot in terms of saying, this is how this works, this is how this works, this is how you connect up to this bit of the system, this is how you connect up to that bit of the system. So basically, the system is so complex that if you're not me or Stefan, then you're going to struggle trying to contribute, even if you know all the programming skills that you would need to contribute. So what needs to happen for me to be able to accept code contributions from other people and make it possible for other people to add their own bits to CQPweb, it needs to be made extensible. So I have to do the groundwork to make it so that other people can extend the system without having to know all those details about the internals and how everything fits together. And that way, it'll be possible both for people to contribute their ideas and their innovations, but also for people who are running their own systems, which they want to apply for very particular purposes, to do that and to set up their own customizations without having to actually hack the main CQPweb code. The main features that people have been asking for a long while are basically these. So the first one is the one that everyone has been asking for in every single CQPweb workshop I've done for longer than I can remember. People want to be able to upload their own corpora into the system, right? At the minute, CQPweb only supports central installation of corpora. It should support users installing their own. It should support interface to corpus construction systems. So if you've got a system for going out on the web and constructing a corpus, it should be possible for that program to link into CQPweb and send its data to CQPweb to set up just in one button press, basically. It should be possible to customize things like the ways in which data gets downloaded. There are a few different options for how you can download your concordances and your other analyses, but it's just a couple of options. There should be more. It should be more customizable because people want to be able to access different aspects of the data that's available. And it should be possible for there to be a wider range of analyses. Again, on the concordance screen of CQPweb, there is a little menu which has got all kinds of analyses on it, but why limit it to just that? There should be more possibilities that you can apply to concordances, to corpora. This includes traditional features, well-known analyses that I don't yet include for whatever reason. You know, I'm not able to do everything. But also, it should include some experimental stuff as well. Particularly, new statistical methods need to be added or capable to be added at a quicker rate than I do with main CQPweb, because in the main CQPweb, I don't add things like statistics lightly, because I put quite a premium on keeping things the way users expect them to be. But if experimental statistics and experimental visualizations and experimental methods could be added via extensibility, then that'd be great. So it's not just about me getting help with the programming, it's also about enabling other people to do more of what they want to do in CQPweb. So one way that I addressed extensibility prior to version 3.3 was by adding a facility for something called extra code files. And this is a feature that I've used it for the BNC 2014 Spoken on CQPweb at Lancaster. And I know of at least one other centre that has used it, and a couple of people from that centre are here. So hello there. Basically, extra code files are files in either CSS, that is cascading style sheets, or JavaScript, which is, and these are the two web browser manipulation languages. And extra code files are files that you write in these languages that insert extra capacities into the concordance screen in the browser. So you can program in an extra code file something that CQPweb doesn't do normally, and then you get an enriched concordance. And the BNC 2014 Spoken is a good example of that. In this concordance, you can see that there are things like the little speaker labels in the concordance context, and you can see them. Normally, things like that wouldn't appear in a concordance because a concordance is the words. By default, speaker labels, which are part of the markup, don't appear. But the extra code can make them appear. And that's what's happening here. So you see things like S0493 appearing, and it appears in blue and bold because you've got the CSS, the style sheet saying that it should. And then the JavaScript comes in to make these clickable. So when you click on a speaker label, you've actually got a link to an extra bit of interface, which is the speaker metadata interface, which is not normally accessible from the concordance. So that was one way of making things extensible that I did quite a while ago. But obviously, this is a bit limited. All it can do is tweak what appears in the browser on the concordance screen. So what did I do, or what am I doing, because this is work in progress, that is beyond that? My decision was to create a plugin system. What is a plugin? Generally in software, when you have a large software system that allows modular chunks of programming that are not part of the base system to be added into the base system as extra units that the base system can then use to do more things that it otherwise couldn't, that's generally called a plugin, because the idea is you've got your bit of code that does a specific job and it is designed to plug in to the main system. Pieces of software that you might be familiar with that make use of plugins are, the number one example that you might be familiar with is WordPress, the blogging platform. WordPress on its own has got all the basic features of running a blog, But if you want to include things like a comment spam filter or extra little tools to include Twitter feeds in the sidebar or all these kinds of things, then you can do that by adding in WordPress plugins. And these bits of code are added to WordPress, and then WordPress uses them to do all these extra things. Well, where might CQPweb be able to allow for downloads? Well, basically the answer is that anytime CQPweb accesses some kind of modular operation, that is an operation that is fairly self-contained, it would be possible, theoretically, for the normal thing that CQPweb does to be replaced with one of these modular bits of code a plugin in order to do that same job in a different way according to whatever the user wants. So how about downloading data files, downloading concordances, for instance, as text files, downloading collocation tables, keyword tables, that sort of thing? Would be nice to allow these to be done in different ways. Installing Corpora. Part of the reason that installing a user corpus is something that I just haven't got round to in years and years and years is because it's a very difficult process. You have to specify all kinds of different settings. Well, what if that task could be given to one of these modular plugins? It would make the whole thing a lot easier because the user wouldn't have to specify all of these settings. Processing concordances. A lot of things on that drop-down menu in the concordance does things like thinning a concordance or sorting a concordance. That is transforming it in some way. Well, that's a kind of self-contained thing. Couldn't that be used for a plugin? So basically, we're looking at places in the system where the normal process could be replaced as a unit by another unit that connects up the right way so that it can work in CQPweb. So let me give you an example. The downloader plugin. In the CQPweb concordance drop-down menu, an option that you've got is download ... And if you press download ... it takes you to this screen. Now, this is the download concordance screen, and it consists of two buttons at the top that give you access to default ways of downloading the data. And then if you don't want to use one of the default ways, you've got a whole set of complex settings, only the very top of which is shown on this figure. And you select all the settings that you want, and then you press download. Originally, these two default ways of doing it were just written into the code. Copied from BNC Web, actually. So, they were part of me following the way that BNC Web does things when I wrote the system for the first time 10 years ago. However, in the newest version, 3.3, these buttons are now generated by plugins. So these ways of doing a default concordance style are they're not there by default. If you just install CQPweb and then don't do any plugging in, they'll just not be there. What you have to do is install and activate the plugins, and you'll get these two buttons. And those are default plugin files that are supplied with CQPweb. Why do this? Why go to all this effort to replace two built-in buttons with two plugins that does exactly the same things? Because it means that if on your CQPweb server, you can add in as many other buttons as you like as plugins. So what you do is you write your plugin, you install it, and then you have, in the admin interface, there is this table which shows the available plugins. And this is just a snapshot of the present state of the downloader plugins. So you install the downloader plugins, and then you use the activate control to determine what corpora have access to what downloader plugins. So these two basic buttons are available in all the corpora that I manage, but if you had a more specialized one, you might want to make it available only for one particular corpus. So that's all controllable in the admin interface, which is the behind the scenes bit of CQPweb that normal users don't see, that controls all the setup. Similarly, Annotator and Corpus installer plugins. Annotator plugins are the ones that take data that people have uploaded and tag them ready for installation. And that whole process then is managed by a Corpus installer plugin, which configures CQPweb's installer process and manages all the files that are needed and all that sort of things. The things that I couldn't work out how to make accessible to a non-administrative user. So what you can see here is that these plugins have lots of configuration settings. So I've just given arrows to one example. This is very small for me. I think that's the UCREL Annotator, I think, isn't it? And the UCREL installer, so-called because it does clause and USAS. So the standard UCREL taggers that we use. So that has got in it the information that is needed for Corpus setup configuration and for and also for the annotator configuration to control which Corpus annotators are used and with what settings. So that plugin now is able to install corpora annotated in that style from files that users have uploaded, and that means that the complexity that was scaring me off implementing this feature is all now contained within that plugin. What that looks like for users installing their own corpora is this. So there is a form in the user page where the plugins that are available to the user are shown as big buttons. They're not showing us buttons at the minute, they're showing us a grid of text. That's one of the bugs in the system that I have to work out. Then you select your files from amongst the files you've uploaded, you choose one or two other options and you push the bottom at the button, the bottom at the button, the button at the bottom, and you get your user corpus installed, and then you get an interface like this on your user page, which lists the corpora that you have installed that are yours, and you can delete them or you can go into them, and if you go into them, they look exactly like any other corpus. So how do plugins work behind the scenes? Each type of plugin, downloaders, annotators, installers, each one has certain rules about what data it receives and what data it produces. So a downloader receives a concordance from command line CQP and produces then the file that the user gets as a download. Now, that means that to write a downloader, all you need to do is to understand those two data formats, what the plugin receives and what the plugin produces. You do not need to understand how to connect up to all the different bits of CQPweb's internals. Similarly, an annotator receives input text, which is going to be the file uploaded by the user, and it produces annotated text, tagged text, vertical format text for import. So to write an annotator, again, all you need to do is know about those two formats, not the rest of the install process. An installer receives a list of input files and produces settings for the install process and annotated versions of the files, but again, doesn't need to know anything else except for how to set things up, as in to say, these are the files I want to include in the corpus, and here are your settings now, and then CQPweb takes that and installs the user's corpus. So because CQPweb is written in PHP, which is, for those of you who don't know it, it's a web programming language, plugins have to be written in PHP in order for CQPweb to use them. And the plugin system is object-oriented. Each plugin needs to be contained in a PHP file, where that PHP file only contains a single class for objects that represent that plugin. So you write that PHP file with your plugin in, you put the file in the right place in CQPweb's code, and that's it. You've installed your plugin. You then have to go into the admin interface that I gave you a screenshot of before to configure it, but then it's done. So what does the plugin look like? Well, this is the beginning of one of my plugins, and this is just a screenshot from my Eclipse. I do development in Eclipse. So if you don't know PHP, this won't be terribly meaningful, but it's just to show you what it looks like. So once this is written, I think this is the UCREL tagger plugin? I think it is. Sorry, I've got, my slides are really small. Yes, so then it gets put in the right place, which is inside the code structure of CQPweb. So the CQPweb code has got a file called lib, sorry, a folder called lib, and inside the folder called lib, there is a folder called plugins, and inside that there is a folder called built-in, and then under that there is a folder called annotators, and so your annotator plugins go there. Simple. Okay, so that's it. That's the system. That's how it works. In order to make CQPweb and the plugin talk to one another, the plugin class has to adhere to an interface. So CQPweb defines interfaces, and the way that works is that the interface specifies what functions the class needs to implement and what data they need to receive and produce. Again, as I said, receiving and producing is what you need to know. And for each type of plugin, there is an interface that defines those functions. So this is how plugins are forced to comply with CQPweb's requirements. So you might ask, oh, this sounds a bit complex. I don't know PHP. I know some other language, Python, Ruby, whatever. Can I only write plugins in PHP? And the answer for right now is yes. However, I'm working on ways to make it possible to connect a very small PHP plugin to a larger program in another language that does most of the actual work, which would allow you to write the biggest part of your plugin in another language as you prefer, and then just link it with a very small PHP class that wouldn't be too hard to write. These are using two facilities that CQPweb has, which are called the ARFace and the PyFace. That's short for interface to R and interface to Python. The ARFace is something that I created for use in the calculation of the log ratio statistic, which was added to CQPweb a while back. For some purposes in log ratio, you can't use just the things that CQPweb knows about already. You have to access calculation of something called a Z statistic, and to do that, you have to access. You have to go outside the normal system, and it does that by creating an interface to R, sending the command to R, and then getting the answer back. So this is just a chunk of code from CQPweb, but what you can see is that in the heart of it, the bit that I've put the circle round, there is just a little string of R code, and that little string of R code is sent through to the interface, and then the result comes back. Now that's just one line of R, but you could easily write a whole script in R and pass it through that way. It would be not a problem at all. And I have actually done that in one or two other applications. The Python face is a lot more of a work in progress. It's a lot earlier stage. But once it's ready, the Python interface and the R interface, they'll both allow you to write a very small PHP class, which fulfills the requirements of the plugin in terms of the functions it has. And then the PHP class, all it needs to do is to pass commands through to the programming language of choice. And then the PHP class just gets back the results and sends them back to CQPweb according to the defined format. That's it. That's that presentation. Are there any questions? Quick questions before I go on to Project Ziggurat, I should say. Long questions we can do at the end. Okay. I'm just going to switch to my other presentation. Right. Is this new PowerPoint up?
It's showing for me.
Thank you. Right, so this is about Ziggurat. So this is the title of the presentation that we're going to do at the conference. What is Ziggurat? Well, Ziggurat is a solution to a heap of problems that have arisen in Corpus Workbench, the core system. So I talked before about how Corpus Workbench at its core is this set of command line programs for managing large corpora and querying them. Corpus Workbench is currently on version 3, and this version is limited in support for certain things that we really need going forwards. First of all, it's got a size limit. It can only deal with corpora up to 2.1 billion words. We need to be able to deal with bigger corpora. It's only got very limited support for XML. It can manage individual XML elements, but not XML trees. And that means that it also can't handle constituency trees. So, you know, if you wanted to encode your tree diagram with noun phrases and verb phrases and so on as XML and handle it in CWB, then that ain't going to happen. Dependency annotation is not well supported. Some people, including people in this talk, at least one person who I know of, have done dependency syntax annotation in Corpus Workbench, but using a kind of workaround that doesn't really, it isn't really as efficient as it should be. Also, the code base of Corpus Workbench is 30 years old, and you can tell. It's hindered by some decisions that were made 30 years ago that made perfect sense then, but perhaps don't make so much sense now. And those decisions limit us from going forwards. So then Project Ziggurat is the idea that the way to get past this is to create a from scratch new data access layer as a self-contained system that will sit at the bottom layer of Corpus Workbench and solve all these issues. So that's what Ziggurat is. It's a data model, data access system that will implement that. And yes, it's a data model and a data access procedure, if you like, and it's also going to be a concrete piece of software to implement this. And Project Ziggurat is our effort to actually get this done. So Stefan Evert and I, who have been doing this, have been intermittently working for about 5 years to define the data model and the file formats. We're working on the principle of measure twice, cut once, which is the old carpenter's saying, except that in this case, we're measuring about 40 times and then cutting once. We're really focusing on the design to try and avoid getting things wrong when we implement it. We're now at a stage where we're trying to define the API, which is the way that programs will be able to use Ziggurat. And after that, we're going to be implementing the actual library functions. Once Ziggurat is finished, the next version of Corpus Workbench will be rebuilt on top of Ziggurat to do the same things that it does now, but with this much more efficient bottom layer. So, introduction to Ziggurat. Corpus Workbench version 3 uses a tabular data model for representing corpora, and you can see that on the screen. The model is that we have columns, and each column represents some aspect of the corpus data. So in column 1, you can see the words of a text, and in column 2, you can see some part of speech tags that have been assigned to the words of the text. And in column 3, you can see the lemmas that have been assigned to the words of the text. So what we have then is the tokens are each on one line, and then the columns on each line indicate different fields of data, which we call positional attributes. But we also have the ability to create regions in the corpus, which is represented with pseudo XML elements. So you can see there that that sentence has got an S tag before it and a /S tag after it, which establishes that this range of tokens is a unit that can be referenced. This tabular data model has been very influential. It's also used by Manatee, which is the software that drives Sketch Engine, and by other systems that you may have heard of as well. So yes, just to give a slightly more complex example, showing how the tabular data model is linked up to corpus positions. Each word that we include in the input data is treated as having a kind of address in the stream of tokens. So this is token 0, this is token 1, this is token 2, this is token 3, and so on to the end of the corpus at token 7. We start counting at 0 because that's programmer's habits for you. The XML elements that create the zones don't have token numbers of their own. They're kind of parasitic on the nearest token to them. So these beginning points are at point 0, this end point is at point 3, and this begin point is at point 4, and so on. So the XML regions are represented as ranges of tokens. So when this text element here is stored in the system. It's represented as a range of 0 to 7. And then the details that go with it are linked to that range. We also encode the corpus into numbers, because numbers are more compact to represent than actual words. So rather than include every word over and over and over and over again in our data representation, we only include every word once. We assign the word a number, and then everywhere in the corpus actual full data, it's referred to by that number. So here you've got the lexicon numbers that are produced. A fine example, 4 different word types, and then very fine examples. You can see that fine does not have a new lexicon number because we've already seen fine, so we use that number again. And you'll see that the same pattern occurs for the other 2 columns. So yes, lexicon IDs for annotation strings. Each of these can be considered an annotation. Even the actual word tokens themselves, in terms of the data model, can be considered annotations. What we do in Ziggurat is we generalize that idea of the data table to a much more kind of abstract level. The idea being that if we define a few very general systems for storing and retrieving data, then that will allow us to make those as good as possible in terms of their efficiency and in terms of how usable they are. And then that will have benefits for all the different forms of corpus data that use those very abstract data structures. So when we abstract things, we start talking about data in terms of layers and variables. What's a layer? A layer is a position sequence. So just as on the previous slide, we saw that 8-word corpus creates a series of positions, 0, 1, 2, 3, 4, 5, 6, 7. That's what is going to be the basis of every layer in Ziggurat, right? A series of positions from the start to the end, 0, 1, 2, 3, 4, 5, 6, up to whatever the size of the layer is, be that 20, be that 20 million, be that 20 billion. So there's going to be two broad types of layer, primary and secondary. Primary layers are just that, they're just a sequence. So a primary layer doesn't actually consist of any real data, it creates a series of slots from the beginning to the end, however long that series of slots is. What goes in the slots, we'll come to that later. Secondary layers also create a sequence of positions, but for secondary layers, the sequences, each item in the sequence is linked to something on another layer, a primary layer, for instance. So a primary layer exists on its own, secondaries are dependent on other layers. We'll see some examples in a moment. Variables are what contain the actual data. So a variable is a set of values associated with a layer. So if a layer has got, let's say, 15 million sequence positions, then any variable linked to that layer will supply a value for each of those sequence positions. So that's what goes into the slots, as it were. And each layer consists of a grid of each of these variables that are defined for that layer. So this is the generalization of the table into the layer is now kind of like the sequence positions, and then we add as many columns as we need in the columns of variables. So we have one value per position sequence, and the variable allows various different types of data. You can have string data, integer data, set data, pointer data, and crucially, having these different data types allows us to implement the best search methods possible for each of those data types, and then those are usable by the Corpus software. Our major principle in designing Ziggurat is KISS. Keep it simple, stupid. As in, we want to keep it all as simple as possible rather than try and produce the best all singing, all dancing, complex way of doing it. So that's why we're using these very general principles. Okay, so what types of layer do we have? The primary layer, the bare sequence of positions, I've already talked about. But then we have 2 other types of layer that I can mention, which will illustrate the idea of a secondary layer being a reference to another layer. So each secondary layer has its base layer, which is the layer it refers to. A segmentation layer is a sequence of ranges on the base layer with beginning and end points. That's just like the XML tags that we saw in Corpus Workbench 3. So for instance, if you've got a segmentation layer representing sentences, it would be linked to the base layer representing word positions. So if you have if you've got sentences beginning at 0, ending at 10, beginning at 11, ending at 12, so on and so forth, then those pairs of numbers would be the link data from the segmentation layer to the primary layer. And so at segmentation layer position 0, you've got the start and end points 0 to 10. At position 1, you've got the start and end points 11 to 12, and so on and so forth down the line. A tree layer has a sequence of nodes where the nodes point to regions on the base layer, but also there is information about the mother, daughter, sister hierarchical relationships, which allows a proper tree to be built, whether that's an XML tree or some kind of syntactic constituency tree. And a graph layer consists, in a graph layer, the sequence items are links between source and target base layers. So that can be from one layer to another layer or from one layer to itself. Each item is a graph edge which points from a position on the source layer to a position on the target layer. And that means that you can then have a directed graph in graph theoretical terms. And then, of course, because that's then a layer, it can be annotated with as many variables as you want. I'm running out of time, aren't I? Because of this system of building layers upon layers, where each layer refers to its base layer, that's why we call it Ziggurat, because it's a huge structure where you have lots of rectangular labels, each piled upon the next. Also, we like the name. So what types of variable can you have? These are the 6 that we've come up with so far. One of the nice things about the Ziggurat approach is that it's constantly extendable. So we've come up with index strings, plain strings, integers, sets, hashes, and pointers. Index strings are where you expect a variable to contain the same values over and over again. So for example, linguistic data, you're going to have lots of words that repeat, or if you're using tags from a limited set. Plain strings are for when you expect a variable that contains text to have unique values, that is, not very many repeated values. So for example, if it's a URL that tells you where a text comes from, then URLs aren't likely to repeat, they're all unique, so plain string. Integers allows you to code numbers. You can code numbers in present CWB, but it's a cheat because they're actually stored as strings. And that means that you can't actually, do any of the shortcuts that them being numbers allows. In Ziggurat, you will be able to. Sets are like index strings, except that you can have multiple values at each position. So that allows a word, for example, to be associated with multiple post tags, for example, if it's been ambiguously annotated. Hashes are like index string, but instead of having a set at each position, you have the equivalent of a Perl hash or a Python dictionary. That is a map of keys to values. And a pointer is just a number that points from the position that we're starting at to a position that we end at, which is similar to the graph layer that we talked about before, except it's just a much simpler implementation for simple purposes. How are these things actually represented in memory and on disk? Well, part of the design of Ziggurat is a specification of what each of these layers and variables is represented as. And this is roughly what it looks like. This is what we call a container file, because although it's a single file, it actually contains multiple different elements that are defined and controlled separately. So each Ziggurat file starts with a header or bill of materials, and the header is the basic information about what kind of thing this is. Is it a layer? Is it a variable? What's its name, what's its unique ID, that sort of thing. And then we have a bill of materials that lists all the components that this variable or data layer contains. The example I've given here is for an index string. These are the different things that an index string needs. It needs a lexicon of actual string types. It needs an index of those strings. It needs a hashed index from strings to IDs. It needs the sequence of lexicon IDs on the layer, and it needs an index of lexicon IDs to layer positions. Whew. Don't worry if you don't understand that. It's not an easy thing to understand. But basically, each one of these is a component of encoded data which exists as a block, but is accessed by its address within the container file. Now, the idea of Ziggurat having a programmable API is that users and applications do not need to know about components. Rather, the component data for each variable type optimizes it for swift retrieval, and the Ziggurat programming library makes that happen behind the scenes, basically. So, index string variables, having all those indexes that I listed on the previous slide means all positions can be retrieved without going sequentially through the token data of the corpus, which is essential because going sequentially through a corpus is slow. Not so that you'd notice if it's 1 million or 2 million words, but when you get into 5 billion, 10 billion, 100 billion words, it gets noticeable. Set variables allow you, in order to do those fast, you add extra lexicons for each item and then for each set of items that we see at different points in the corpus. This allows us to create all kinds of different corpus data patterns. And there really is no way to explain all these in any coherent way in the time that I've got. So I'm just going to flip them up. So that's just a sample of the things that we can do in a really good way there. We can do full XML structures. We can do simple UD dependency parses. We can do sentence alignment for parallel corpora using a graph layer. We can do multiple concurrent tokenizations for a corpus that you've got multiple programs that split up the words in different ways. All kinds of things become possible. Ziggurat, as I said, is a library, which means it's going to have an application programming interface. There aren't going to be actual programs. It will have API bindings for multiple languages to allow programs using Ziggurat to be written in the way that people prefer. In Corpus Workbench version 4, we will have a corpus management library that is a user of Ziggurat, and then other libraries as needed will be added to the system, for example, to parse the syntax of CQP queries and then compile finite state machines to implement them, or libraries for the user interface, and so on and so forth. The actual programs will then be quite small, and they will just use these libraries. This is one of the areas where Corpus Workbench 3 kind of falls down. It's not designed neatly in this way, but using Ziggurat will allow us to do that. Yes, and other applications will be able to use Ziggurat in much more flexible ways than it is possible to interface with the current version of Corpus Workbench. So, for the sake of your illustration, I came up with an example, and this is a hypothetical example. This is all work in progress. The final thing may look very different. But I'm imagining that you want to write a program that does things in Ziggurat using Python. Let's say Python is your main programming language. Well, the Ziggurat library, which is written in a much lower level programming language, will have bindings for Python, which means that there will be, you know, if you've got your Ziggurat installed, right, there will be a module for Python called Ziggurat. So that script on there shows us importing the Ziggurat model. And then on line 9, you simply create a new Ziggurat object, and that's your Ziggurat data store, your collection of layers and variables. The layers and variables have to actually be added to the data store. So we do that by saying store.addObject, and then the different paths that we're looking at. And we need to wrap that in a try except, because that can go wrong. And so we need to check for that. I'm not going to do any more of that, by the way, in this second part, because it would make it too long. But then you can do things like you can check the types of different variables. So wordvar, we find our word variable by seeking a layer from the store, and then once we've sought the layer, we seek the variable, and so we get the word variable on the primary layer, and then that object then allows us to check the type of the variable, which happens on line 24, and then on line 43, I think, we do a regular expression query for elephant.star, and that returns us all the lexicon IDs of words that match that lexicon, that match that regular expression. So we'll get elephants, elephant, elephant-like with a dash, so on and so forth. And then we can print out the number of results that we've got. Now, this example, you might look at it and you think, well, why wouldn't I just, use CQP and type in the query elephant.star? Well, there's no benefit. But with this, Ziggurat can be used to do things much more complex than what you do in a pre-designed program, right? So the idea is that as people like Doug Biber and Stefan Gries have been arguing for years, it should be possible to do, it should be possible for corpus researchers to program their own techniques. But as I've been saying for years, the more complex bits of corpus programming, like indexing and data retrieving and all of that stuff that we saw at the Ziggurat level, it's not efficient for every corpus linguist to replicate that. So instead, we provide the Ziggurat library with the bindings, and then people can exploit it by learning kind of high-level programming and not having to get into the complex stuff. Conclusion, Ziggurat is still in its very early stages. We welcome comments and suggestions. On the Corpus Workbench website, there are the working documents. They're actually quite old now. I need to post new versions fairly soon. Our aim in terms of development is to have a 0.1 version for people who are very adventurous to try out by July this year. I say 0.1, that will be liable to change and probably full of bugs. Any questions? That's the end. Thank you.
Thank you very much, Andrew. I will stop the recording now.